High above the dense jungles of the Yucatan Peninsula, an ancient civilization looked to the heavens with a mathematical precision that still baffles modern scientists. The Maya weren't just city builders, they were masters of time and space. While Europe was wandering through the early Middle Ages, Mayan astronomers were calculating the lunar cycle with a margin of error measured in mere minutes. They saw the cosmos as a rhythmic, predictable machine. But how does a culture that peaked over 1,000 years ago influence the way we view the universe today? From the way we track deep space objects to our understanding of cyclical time, the Mayan legacy is everywhere. At the heart of their wisdom was the concept of zero. Long before it became a staple of Western mathematics, the Maya used this placeholder to perform complex calculations. This mathematical prowess led to the creation of the most accurate calendar in human history. They understood the solar year was 365 days, but they also accounted for the subtle drift of time. Modern NASA scientists have used Mayan records of solar eclipses to help calibrate Earth's rotational history. By looking back at their data, we can see exactly how much our planet's spin has changed. The Maya were obsessed with Venus, which they called Chak Ek. They tracked its 584-day cycle with such precision that their tables remained accurate for centuries. This focus on planetary cycles laid the groundwork for modern celestial mechanics. We use the same orbital math today to send probes to the outer reaches of our solar system. They also recognized the precession of the equinoxes, the slow wobble of Earth's axis that takes 26,000 years to complete. This required generations of meticulous record-keeping. In the 21st century, archaeoastronomy has become a vital field. By using LiDAR technology to peer through the jungle canopy, we are discovering cities aligned with constellations. This wasn't just about religion, it was about survival. Understanding the stars meant knowing exactly when to plant and when to harvest, creating a sustainable civilization. The Mayan long count calendar was never meant to predict the end of the world. Instead, it was a profound realization of the universe's infinite, repeating nature. Today, we see their influence in the way we structure our leap years and observe planetary conjunctions. The Maya taught us that the sky is a book we must learn to read. As we look toward the future of space travel, we carry their curiosity with us. They proved that with nothing but stone and shadow, the human mind can touch the universe. The Mayan legacy isn't just in the ruins of the jungle. It's in the data points of our most advanced telescopes. They were the original guardians of the galaxy. To truly understand how deep this influence goes, we must look at their precision with the lunar month. They calculated it with staggering accuracy compared to modern atomic clocks. This wasn't a lucky guess. It was the result of thousands of years of observation, passed down through generations and recorded in bark paper books called codices. But the knowledge that survived changed everything. When these concepts reached Europe, they helped ignite the scientific revolution that gave us the modern world. Modern astronomy is a conversation across time. Every time we track a comet, we are speaking the language of the Maya. They taught us that time is a beautiful circle. From the depths of the rainforest to the farthest reaches of the cosmos, the Mayan spirit of discovery continues to guide us. Their eyes were on the stars, and now ours are too. The Maya were also pioneers in tracking the Pleiades star cluster. They used its movement to mark the beginning and end of sacred periods in their 52-year calendar cycle. This 52-year cycle, known as the calendar round, ensured that no 2 days shared the same name for over half a century, a feat of temporal organization. In the modern era, we use similar leap-second adjustments to keep our global positioning systems and atomic clocks in sync with Earth's celestial position. The Dresden Codex contains a table specifically for predicting solar and lunar eclipses. It was used to prevent panic, turning a frightening celestial event into a scheduled ritual. Mayan buildings like the Temple of the Sun at Palenque were built with windows that act as light boxes, capturing the sun's rays only on the winter solstice. This architecture of light is a direct precursor to modern sustainable building designs that use solar orientation to maximize natural energy and illumination. The Maya also catalogued the great conjunctions of Jupiter and Saturn, events that occur only every 20 years and were considered omens of great change. Our modern fascination with these conjunctions, often called the Star of Bethlehem, continues to drive public interest in amateur astronomy and telescope sales. The Maya believed the Milky Way was a world tree or a road to Xibalba. This poetic description matches the modern scientific view of our galaxy as a structured, spiraling entity. They were among the first to realize that our Sun is just one of many lights in a vast, interconnected system. Their humility in the face of the infinite is their greatest lesson. The mathematics of the Maya were base 20, or videsimal. This system allowed them to handle enormous numbers with ease, a necessity for tracking cosmic timescales. Modern computer binary, base 2, is a distant cousin to this conceptualization, breaking down reality into simple, repeating, logical structures. The E-groups in Mayan cities like Huachatún were specialized building complexes designed solely to observe the Sun as a position throughout the year. These were essentially the first permanent scientific laboratories in the Americas, dedicated to the long-term study of the physical world. Modern solar observatories like those in Hawaii or the Canary Islands carry on this tradition of placing high-precision instruments in optimal geographic locations. The Maya tracked the 584-day synodic period of Venus by observing its heliacal rising, the moment it appears in the morning sky just before sunrise. This event was so important, it dictated the timing of wars and the crowning of kings, showing how deeply the stars influenced their geopolitical landscape. Today, we see a similar intersection of space and power in the space race, where lunar landings and Mars missions become symbols of national prestige. The Mayan concept of Baktuns, periods of 144,000 days, showed a comfort with vast timescales that mirrors modern geological and astronomical epochs. We now use the term Anthropocene to describe our own era, but the Maya were the first to recognize that humans are part of a larger cosmic timeline. Mars was also part of the Mayan catalog. They associated the red planet with fire and the god of war, tracking its retrograde motion with startling accuracy. This looping motion in the sky was a puzzle for ancient astronomers everywhere, but the Maya integrated it into their ritual cycles flawlessly. Today, our Mars rovers, like Perseverance, rely on these same orbital calculations to time their descent into the Martian atmosphere. The Maya used a base 20 system that included the use of place values, allowing them to record numbers into the millions and billions on their stone monuments. This was a level of mathematical literacy that wouldn't be seen in Europe until the adoption of the Hindu-Arabic numeral system centuries later. The Mayan Dresden Codex also includes a Venus table that tracks the appearance of the planet as both a morning and evening star. This dual nature of Venus led to a sophisticated mythology that governed their calendar of ceremonies and sacrifices. In modern physics, we understand this as the same object appearing in different parts of our orbit, but for the Maya, it was a cosmic drama played out on the stage of the sky. The city of Chichen Itza features a pyramid known as El Castillo, which serves as a massive solar calendar with 365 steps. On the spring and autumn equinoxes, the shadow of the pyramid's tiers falls on the staircase, creating the image of a slithering feathered serpent. This Serpent of Light proved that the Maya could manipulate light and shadow on a massive scale, essentially programming their buildings with data. Modern architects use similar light modeling software to ensure that skyscrapers don't create wind tunnels or block essential sunlight from public parks. The Maya were also among the few ancient cultures to track the cycles of the Great Eclipse, a series of eclipses that repeat over 18 years. This 18-year period, known as the Saros cycle, is still used by modern astronomers to predict the recurrence of solar and lunar eclipses today. Mayan culture reminds us that astronomy isn't just about looking through glass lenses, it's about the patient accumulation of data over centuries. Their legacy is a bridge between the deep past and the deep future, a reminder that we are all travelers on the same cosmic journey. Every time we look up and wonder about our place in the universe, we are repeating a gesture that the Maya perfected 1,000 years ago. They reset the map of the heavens for their time, and in doing so, they gave us the tools to map our own. Mayan culture didn't just influence astronomy. It proved that the human spirit is designed to seek the truth, no matter how distant it may be. Thanks for joining us on this journey through time and space. Don't forget to subscribe as we continue to explore the hidden history of our world. Until next time.